Alright, introducing ViperProtect. It protects your art in 3 ways. First is the poison imaging model. Second is regular watermarks, and third is a scraping function. So we can upload, for example, images like Will Smith and such. So I'll upload this guy. We can like blur it, and we can set passwords. So blur, copy link, and we can process another. And we can do, for example, Viper watermark. So we'll skip the protect. For example, now you can see that it's a Viper watermark. Process another. Now this is the main feature here, Viper poison. Normally it takes 2 minutes to run, but if I put this in here, press Viper poison, this is what I would get. So you have your original here, you have your view original. This is what the AI actually sees and puts in the system. This is our poison. As you can see, there's a little bit of quality loss, but it keeps most of the main features intact. And here's the AI view poison. As you can see, it's completely distorted and configured. So it would be useful for AI model training. We can also copy this link and put it on here. And as you can see, this is to allow artists to share their images without the worry of it becoming stolen. Now, this is obviously a protected image. For example, if I wanted to put this here, and I wanted to pixelate it, you can also download the image after you pixelate. So we'll set a password 12, we can protect it. Now it's pixelated, we can copy the link, and since it's all hosted to the cloud, anybody can try this. I can send this to my friend, and he'll put this link, and this will open up on his page. This isn't local hosted at all, except the backend of the GPU. The other backend is actually hosted through Fast API on DigitalOcean. Now we can download protected. We can do 1, 2, 3. I think. Let me just do another one again. I forgot the password. Apply to this. So 1, 2, 3. Protect. Copy link. As you can see, it generates a specific ID for each one, so you can find it. Right now, if I enter like a wrong password, it doesn't work. 1, 2, 3. Lock original. And I can download the original file. There's also scraping things, so there's a bunch of invisible links on the website. So if a scraper ever picks them up, it gets stuck in an auto generation loop where it just feeds it garbage data. So it protects images in that way too. And we also have, very coolly, custom images where you can do images like this. You can record, put in your custom watermark, you can save it, and you can also edit it. You know, I don't like this part, save it, and you can download it. And you can also just process this again with like blur or something. So protect, and now it's blurred. And copy, again, download options such as that. The main way this works is it takes the image, it gets an encoding of it. Now normally when you decode it, it outputs an image which has all the significant features of this image. So for example, on this, we inputted it. It won't be the exact same here, but it keeps the main features that the model needs to train on. Our poison image, it goes in the encoder. When it decodes it, garbage, like here. This encoding goes into the diffusion model, and we get corrupted output. More on how this works is we first get the Python image, load it into a tensor. We have 2 separate encoding models. We have the VAE, which is more for like diffusion models, and we have CLIP, which is more for like robot learning. We have a loop. We have delta, which is essentially a way to keep track of pixel changes per loop. We blur the image. This prevents companies from just resizing the image to get rid of the poison. So by blurring it, we only keep the strongest poison possible. We throw the encoding in the VAE and the CLIP, and we compute the loss. Now normally loss is computed, we want to minimize it. Here we want to maximize it because we want the complete wrong encoding with a little change to the original image as possible. So we compute the weighted loss of this, and we do a backward gradient descent with of loss respect to delta. We get delta. We put in the delta, the gradient steps for each specific pixel. We add it to the image, so now the pixels have shifted slightly. We loop this again. For example, here on the original thing, it has all the different steps, and these are all the specific batches. And as you can see, the loss is getting much worse each time. We save it to the final thing by adding the image plus delta as we've done before. We take this tensor, convert it back to image, and we return it as a fast API deployment. Over here, this is through just local hosted through ngrok, but normally our backend is actually hosted on digtalOcean. Frontend is hosted on digtalOcean. We used spaces of digtalOcean, and the database is also on digtalOcean. Yep, that's our main idea, and this should help artists have a way to share their images in a very safe way and not be worried about AI models. And good thing is, this, if we got a faster GPU like a Scala GPU, this would run extremely fast.